Good morning, my YouTube viewers. It's Crystal here. I'm just here because I wanted to make a video on Kaggle's playground competition, season 4, episode 8. It's taken me a little while to get this video made, and the reason why is because they were doing work in my apartment and I couldn't get into my apartment to get my computer and make the video. And I was using my boyfriend's Chromebook, and somebody did something to it, and I was able to use it to make videos. But I couldn't make videos. I was able to use it to work on Kaggle or something like that, but I couldn't make any videos. I did figure out how to do a screen recording, but I couldn't upload the screen recording onto YouTube or anywhere else. And then I crashed the video, and then when I crashed the video, or crashed the computer, and when I crashed the computer, the video was gone. So I had to wait until I got back into my apartment to make the video. So now you're seeing the video that I made more than a week ago, but at least you get to see it now. So this is Kaggle's Playground Competition, Season 4, Episode 8, and it's to determine whether mushrooms are edible or not. I got a 96.9% accuracy on this, on the predictions that I made, and I worked on it quite a bit. This particular model that I used was extra trees, and I got the highest value on extra trees than I did any of the other models, such as random forest regressor or random forest classifier or hist gradient boosting classifier. So the first thing we're going to do is we're going to go over the problem statement, which is predict whether a mushroom will be edible or poisonous. And then we're going to import our libraries. We're going to import NumPy as NP, Pandas as PD. NumPy performs your numerical computations and makes NumPy arrays. Pandas creates your data frames and processes the data. Import OS, which goes into the operating system, and it's going to retrieve the files. We're going to import SciPy to perform the Kolmogorov-Smirnov test to see which columns of data are from different distributions. We're going to import sklearn, which provides your machine learning functionality, and we're going to import matplotlib to visualize the data, and we're going to import Seaborn to further visualize the data statistically. And so I forgot to mention that this Jupyter Notebook is saved in my account in Kaggle, but what I will do is I will leave you a link to the Jupyter Notebook so you can look at the Jupyter Notebook if you want to. We're going to use OS to retrieve the files, and so the files that are in the system are train, test, and sample submission. And I also would like to say that whenever you're working on your Jupyter Notebook and you're working on your module, if you can't get the accuracy to be what you would like it to be, you can always study other people's codes, because the thing about Kaggle is that Kaggle allows people to make their code public, and I make all of my code public. But you can study other people's codes and see what they did to get an accurate prediction. And I couldn't get a good prediction, and I had to actually study somebody's code. And then whenever I studied their code, I found out what I was doing wrong. And the thing is because I'm a self-taught data scientist, some things I don't know, being self-taught. And so it does, it is useful to look at other people's code, see what they did, that they may have more skill than you do, and they may have been able to solve a problem that you couldn't solve. And if they're kind enough to put their code up on Kaggle, then you should just go ahead and look at it. And that's how I improved my score in this particular competition question, was looking at somebody's code, and I will show that what I found when I get to that point in the program. So now what we're going to do is, after we have retrieved the 3 files, train, test, and sample submission, we're going to use pandas to read the CSV files and convert them into data frames. But before we do that, what we want to do is we want to set it up so we can see all of the columns of data. So that's pd.setOption brackets display.max columns, comma, none. And that will allow you to display all of the columns of data. And then after we've displayed all the columns of data, we use pandas.readCSV to convert train, test, and sample submission to data frames. So here's your train. And the target is going to be class, and class is going to be either E or P, so edible or poisonous. We look at the info, we see we've got a few floats, but the rest of them are object columns, which means they're going to have to be encoded. So we're going to go ahead and drop the duplicates. I don't think that we had any duplicates, but I found this drop duplicates from somebody else's code, and I decided to use it. So yeah, if there were any duplicates, then you would have been able to drop the duplicates. But the thing is you can only drop the duplicates on the train set. You can't drop the duplicates on the test set, and the reason why is because Kaggle wants to have the same order in the test set. But if you want to drop the duplicates on the train set, you can. So that's what I did. I dropped the duplicates. So we're going to check for any null values, and you see we've got lots of null values that need to be imputed. And then so here is a chart, a graph featuring all the null values. So if you like looking at diagrams, here's the null values as it appears in a Matplotlib bar chart. And so now what we're going to do is we're going to encode all of the, we're going to impute all of the null values. So if the null value is a integer or a float, then I'm going to replace it with median. And if it's an object, I'm going to replace it with not listed. You could put mode if you want, but I didn't want to. I prefer to use not listed. And then you've got lots of warnings. And then after we've imputed the null values, you'll see we don't have any more null values. So we're going to look at test, and test is the same as train with the exception it does not have a target, and that's what we're going to predict on. Test also has a lot of null values. So we've used this Matplotlib chart to make a chart of null values. So you can see all the null values there. We've got quite a bit. Now what we're going to do is we're going to impute the null values, and the imputation is going to be exactly the same format that we used for train. So if the column is an integer column or a float, then we're going to impute the null value with median. But if it's an object, we're going to impute the null value with not listed. Got lots of warnings. Then we're going to check for null values again. You see that we don't have any more null values, so that's good. So now we're going to look at the submission, and submission is going to be either an E or a P. So what I did was I used SciPy to perform a Kolmogorov-Smirnov test to see if there were any columns of data that were not from the same distribution. Because if you have any columns of data that are not from the same distribution, then obviously that's going to affect your prediction as well. The only columns of data that I found that were not from the same distribution were the ID column. But the thing is whenever I did this, I forgot the target column was like in column number 3. So it didn't work out correctly anyway. But anyway, I still checked to see which columns of data are from the same distribution. And what I should have done was I should have done something a little bit differently. I should have taken out the target column before I had done it, but I didn't do it. But I decided not to use it anyway. And so now we're going to drop the ID column. And so we've dropped the ID column. You don't need the ID column because Pandas automatically indexes each row of data anyway. So now we're going to analyze our target. Now what I should have done is I should have put the Kolmogorov-Smirnov test after analyzing target, which I didn't do, but I didn't use it anyway. So target equals train.pop class. When you pop the class out, that means it's gone forever. And then now what we're going to do is we're going to do a seaborne disk plot of the target. So you'll see that you've got like E slightly less edible than you do poisonous. So now what we want to do is this target is actually a NumPy array. So what you have to do is you have to get all the unique values from the target. So unique values, comma, counts equals NP unique target, comma, return counts equals true. For value count in zip, unique values counts, print F value occurs count times. So E occurs 1,411,549 times, and P occurs 1,705,396 times. Okay, so now what we want to do is we want to encode the target, and we're going to use sklearn's label encoder to do that. So we're going to take the E and P's and we're going to convert them to 0 and 1s. And so we're going to encode the ordinal values. And this is one thing that you need to do is because in the test file, you have different data that you have in the train file. And so it has to be ENC equals ordinal encoder, handle unknown equals use encoded value, and then unknown value equals -1. You have to do that. If you don't do that, then you're going to get a low accuracy on your prediction, which is what I found. Then so for column in train, if train call.dtypes equals object, train call equals enc.fit transform, train call.values.reshape -1, 1. And on the test has to be transformed. So the train has to be fit transform and the test has to be transformed because you're transforming it on the train set. And the thing that you need to keep in mind is if you put fit transform in the test one, then you're not going to get a good accuracy. The test file has to be transformed on the train file. So now we're checking the info of train, and you can see that it's all numeric values now. It's all floats now. Now what we've done is we've created a heat map on train. So you can see here on the heat map that all of the columns of data have a low correlation. The reason why they have a low correlation is because they're a dark color. And then if you have a lot of columns of data that had a high correlation, which means a light color, then what you could have done is you could have removed the columns of data that had a high correlation. But in this particular one, there was no high correlation, so I didn't do it. And the thing that you need to keep in mind is, like, when you remove columns of data, then what you have, you're going to potentially sacrifice accuracy. So that's another thing that you need to keep in mind. So now we're going to define our x and our y variables. Y equals pd.series target. You have to do it that way because if you don't do it that way, when you try to make predictions, it's not going to work. X equals train and x test equals test. So now what we're going to do is we're going to set class weights, and this is a function that I developed with help. I had help, to define the class weights. So we're going to have a function called calc class weights. Class values equals y dot value counts. Num classes equals len np unique y. And then you have weight is a blank list or a blank array for element and range num classes. Class weight equals len y over num classes times class values of element, and weight dot append class weight. Class weights equals dict zip np unique y weight return class weights. Class weight equals count class weights y, and then you're going to print your class weight. So whenever we looked at our target, it wasn't very unbalanced. So your class weight is going to be 1.1 for 0 and 0.9 for 1. But if you're working with an unbalanced data set, then it's going to be a lot different than that. So now we're going to normalize the data, and what's going to happen when you normalize your data is you're going to take all of the values and you're going to convert them to a value between 0 and 1. And so you can either normalize the data or standardize the data, but I decided to normalize the data in this situation. And then now what we're going to do is we're going to split the data set using sklearn's train test split function. We're going to have a test size of 0.1, random state of 42. And so x train, x val, y train, y val equals train test split, x comma, y comma, test size equals 0.1, shuffle equals true, random state equals 42, stratify equals y. And then you get your shapes. So you can look at your shapes, and then that kind of like tells you whether you're on the right track when you look at the shapes. Now we're going to define our model, which is going to be an extra trees classifier. Random state equals 42, class weight equals class weight, fit x train, y train. You get a score of 100%, so that's good. That's why I like to use extra trees. Now you're going to predict on the validation set. Ypred equals model.predict xval, and then you're going to come up with an array of zeros and ones. You're going to check the accuracy of the validation set, and you have a 99% accuracy, and we're using sklearn's accuracy score to do that. We're going to perform a confusion matrix, and this confusion matrix will tell you how many true positives, false positives, true negatives, false negatives you got. So and that just gives you an idea of how many false positives and false negatives you've got. We're going to create a data frame of the actual values and predicted values, so you can look at that and see. Now what we're going to do is we're going to predict on the test set. Prediction equals model.predict x test, and then the prediction is an array of ones and zeros. And now what we're going to do is we're going to use Seaborn. Oh no, and then first what we have to do is we have to inverse transform the label, And the reason why we have to do that is because in the beginning of the program, we transformed it from EMP to 0 and 1 or 1 and 0. And so now what we have to do is, because Kaggle wants to see EMP, we have to inverse transform the prediction. And then this is using Seaborn to make a chart of the prediction. And one thing that I forgot to do, I said SNS just plot prediction. I should have done comma KD equals true, and it would have given you a little line to go through it. But I didn't do that. I forgot to do KD equals true. So you can see that you do have a mild class imbalance. You have less E's than you have P's. So now what we're going to do is we're going to prepare our submission to Kaggle. Submission class equals prediction. Submission.toCSV equals submission.csv. Index equals false. Submission equals pd.readCSV submission.csv. And this is the submission. And so this is what we submitted to Kaggle. And whenever I submitted it to Kaggle, I got a 96% accuracy, which is pretty good in my opinion. And I did actually try other models to see if I could get a better accuracy using other models, but that's the highest accuracy that I could get. And I was working on this at my boyfriend's mother's house on his computer, his Chromebook, under guest mode. And so there you go. That's what we got in this particular competition question. And at least you know now why it took me so long to get the video made and the blog post made as well. So thank you so much for watching my video. If you liked it, please like and subscribe. And I look forward to communicating with you in the next video.